Let's start. So, hello, I'm from RISC OS Open. Many of you already know me. I'm going to try and avoid repeating the things that I've said many times in the past and stick to the new stuff. So I'll start with what we've been doing, what's been happening in the community since probably about a year ago. I'm going to touch on how the bounties are looking, our bounty scheme. There's a bit on Raspberry Pi 4, which is a bit of a hot topic at the moment. I'm sure quite a few people are interested in that. And then some hints about where we could be going next. So initially, our bit that we've been talking about for more than a year was to move RISC OS from its old legacy way of being managed as a piece of source code to a more modern system called GitLab. And this is now open to the public. So we've done it, we've published it, and there have been already quite a lot of changes and improvements to RISC OS fed through this system. And one of the big benefits of this system is it's all out in the open. So you can submit your code changes, you can get feedback from people reviewing the code changes. That feedback is all there. Whereas in the past, it all felt a bit opaque. Someone would send us an email with some changes in it, and then we'd sit there and scratch our chins and then send them some feedback and say, we need you to change it like this. It's a lot easier now to just see what's going on with RISC OS development if you're interested in that side of things. It's industry standard, so it's not the only way of doing these things, but it's a very popular way, which means that new developers coming into the scene have one less thing that's really weird about RISC OS that acts as a barrier. So if you're interested in this stuff, you can easily find it from our website. Another thing that's changed quite recently is we ploughed through the disk image, all the stuff that comes alongside the operating system, like the applications and utilities. And we've packaged them all up, finally, so that the system called Pac-Man that we've been supplying since the Raspberry Pi came out, we've been supplying it as part of the RISC OS disk image. It's a package that basically you load it on the icon bar and you can look through the list of all of the packages that exist in the RISC OS community, and you can just tick stuff and download it and install it on your machine through Pac-Man. And we've made sure that all of the independent bits and pieces of applications and third-party stuff that we've been bundling up and sending out with the disk image, they're all managed through Pac-Man now. So you can easily find out if some application that you have on your machine has been updated, because every time it's updated, we build the updated version and publish it here. And Pac-Man will spot that, and it will say, oh, there's a new version of Omni Client. Do you want to install it? Yeah, go on then. And it will update your copy of Omni Client to the latest one. So there's more to come, because the core of the boot sequence, that clean boot folder, isn't managed yet through Pac-Man because it's a bit thorny, and there's some problems there that we still need to figure out how we're going to solve them. But I think this is a really good move. It's what I was kind of dreaming of happening when Pac-Man was first released. The idea that you can just find out what the latest version of stuff is and automatically download and install it is brilliant. It takes away so much faff from an end user perspective. Another thing that's happened in the last year is we closed off one of the big bounties that we had open to improve security of internet connections on RISC OS applications, and this was basically to obsolete a whole load of insecure protocols that RISC OS supported in its Acorn SSL module and replace them with the modern equivalents. It was quite a big, thorny bounty, and pleasingly it has been completed and all delivered. And it's all released for free as part of what you get with RISC OS nowadays. So I'm really pleased about that. It's setting some of the foundations for what we need to do above and beyond that in the internet stack, and I've hinted here things like Wi-Fi support, You can't have creaky old 20-year-old security technologies and then just magically switch on the ability to do Wi-Fi. You're going to have problems. So this is a stepping stone. It's an important one, and it's been done.
You seem to be updating those certificates quite frequently.
Yes.
Are they going to be released via Pacman? Can they be released via Pacman?
So at the moment, yeah, they live inside Plain Boot. So no, they're not managed through Pacman. When we figured out, and they're one of the problems, when we figured out how we're going to subdivide all the bits inside, you know, the bit with all the printer definition files, the iNet res application, Plin configure, and all of its constituent plugins. All of these bits need carving up into a way that we can package them independently, and hopefully just put them under the umbrella of boot. And I want to update my boot, please, and get all the latest certificate authorities and all the rest of it. So we'll solve that problem. We've just not solved it yet. Another bounty that has just closed was the compiler improvement bounty, which is a bit technical, but the important thing is that as ARM processor architecture keeps moving forward, if we don't keep the toolchain moving forward with it, we're going to have some, at the very least, we're going to find that the code we write and we generate when we compile the source code into the thing that actually runs is not going to be as effective as it would otherwise be if we leveraged all the new stuff that comes in the new architectures. So, broadly speaking, that stuff all happened. It was another quite meaty bounty, and that's all been done. So the latest version of our developer tools include all this stuff, but it also means that that's the tools we're using to build RISC OS. So the versions of RISC OS and the applications that we release on our website are being built with these tools now. And one of the side effects was, for example, the titanium, because the toolchain now actually supports the architecture of the chip inside the titanium, it turned out to be significantly smaller, the final thing that it built, because it was using better instructions that better suited for the purposes. It's probably also minutely faster, but you won't be able to notice that. We've also brought some updates to the toolbox manuals, which are included as part of the developer tools in PDF form, I think. The compiler for BASIC, if anyone uses ABC compiler, that's also had a couple of minor bug fixes, but it's also been modified so you can run it directly from a command line, so you can build it into a Makefile or something like that. Whereas before it was just a desktop application, so if you wanted to build your basic, compile your basic program, you had to load the application and click on stuff. We'll announce all of this stuff in the imminent future when someone starts typing, as in me, and writes it. Bounties. So I'm not going to tell everyone what bounties are, because you all know roughly what the bounty scheme is about. If you don't, please chip in with questions. But the long and short of it is, it's had a reasonable amount of money, and this is super generous. The people who've contributed this stuff have basically sponsored important developments in and around RISC OS that would not, I contend, these things would not have happened if the community hadn't reached in and put some money into these bounties. Because some of these problems, some of these features that we've developed are sufficiently big that you have to take time out of your paid work to develop the code. And it's hard to do that for free. Not many people can manage to do that. So the bounty scheme is really helping there. I've already recapped the stuff that I just talked about was the result of bounty work. We've got some in progress right now, so there are developers actively working on some new features right now with the bounty scheme, and there's a few more bounties that are sat there just waiting to reach the right total for a developer to say, yeah, that's enough, I'll do that. There's more to talk about there, but I'll come back to it. Here's what's currently being developed. Is it? Yes, yes. So you can see quite a bit of it is getting close. Improvements to Plin Paint. Lots of people use Paint. It's handy, but there's loads of things that it doesn't do compared to modern bitmap editors. There's quite a lot of useful improvements here. For example, supporting pings. Filing system improvements. There's quite a lot of work to do still. And we've got some various other bits. One thing I would just call out is these things, it really helps to have people in the community volunteer to try these things out while they're in development. So reach out and get in touch with us if you want to be a beta tester of any of these things, and we can connect you with the person doing the development so that they can send versions for you to test. Because the more we can flush out the rough edges of these things before the bounty is complete, the better, because then you deliver something out to the community at the end that's nice and polished. No one wants to be putting out stuff and then finding where all the bugs are. Unless you're Microsoft. TCPI, these are the ones that are still open, and we are looking to collect enough money to kind of get them over the line. I want to say something about these two, these network ones. TCP/IP just basically means networking. Those two are really important to the future of RISC OS, in my humble opinion, because they basically mean, this one means Wi-Fi support, and later there'll be a further bounty that would be IPv6, which is, I think, less compelling than Wi-Fi support. But what we know about Wi-Fi support is, to add to that, we have to do quite a significant overhaul of all the networking software in RISC OS, hence this one. So the first step was security, the second step is overhaul all the plumbing, and the third step is bolt some Wi-Fi support on top. And I think most of us can see the benefits of having native Wi-Fi support in RISC OS. They are quite meaty projects though. I think, I had a quick look earlier, I think they come to, in total, our guesstimation, if you paid someone £10 an hour McDonald's salary, they would come to about £20,000 worth of development. So if you divide by 10, that's roughly how many man-hours we assume it would take to do these two bounties. And I think we're about £10,000 into that, so we're roughly halfway into building up the bounty pots. But one thing I think would be an interesting conversation is for me to talk to the guys at RISC OS Developments and say, is there some way we could work together? You've got a pot of money and a need for Wi-Fi. We've got a need for some money in a pot. Maybe there's some way we can work together and get this stuff over the line sooner rather than later. Because I think if we leave it at its current pace, we're going to be looking, several years down the line before we get all this stuff, which for me feels like an eternity. And this toolbox reunification is interesting to all of those people who have come from the RISC OS 4, RISC OS 6 side of the tracks. A lot of good stuff happened on the RISC OS, as we all know. A lot of good development happened on that side, which didn't carry into the Castle fork, into the RISC OS 5 fork. We would like to try and pull across a lot of the good features that came from there into the RISC OS 5 fork. So there's a bounty there about making sure that we can pick up a lot of those features. Pi 4. So I'm sure most of you are aware that a new Raspberry Pi came out not too long ago, certainly in this year. This was, unfortunately, we knew about this before it was released, but we weren't in any position to move the RISC OS port forward so that we could support it when it was released, which kills me because it means that this new product has come out and RISC OS out of the box cannot run on it. I wish we could be ahead of the curve for new Raspberry Pi releases, but it's just not the case. So we've been playing catch-up and trying to make RISC OS work properly on the Pi 4. And a lot of progress has been made, but it's been something of an uphill struggle. Mostly because there's almost no documentation about how the thing works, and it's quite significantly different to the earlier generations of Pi. So there's a lot of stuff that needs to change. And we have a good relationship with the guys at Raspberry Pi, but even they can't give us documentation because quite often they don't have it either. So I'm kind of scratching my head at how the Linux people did their ports. But we're basically more often than not, we're having to look at how Linux works and figuring out how the Pi works from looking at that code. And we'll find ourselves looking at some code that pokes a magic number into a magic address and going, oh, I wonder why that does that. Let's try poking a number into that address and see what happens. So there's been an awful lot of that. And sometimes good things happen, and sometimes less good things. So we have crossed off some things on the list of, this one was a pain, it's done now. USB support, it's not easy to use a computer without USB working. It's quite hard to type and move a mouse around. We have made progress recently in the last few days, maybe the last week or so. We can now see the USB controller through this PCI tunnel. So this is an important technical step full of acronyms, which means we are now in a position where we can start directly driving the USB controller and getting devices working again. So we believe, wet finger in the air, that we've got maybe 1 or 2 man weeks of work left to get USB working. Ethernet is a whole different kettle of fish because there's no commonality to anything we've already got. We just have to do it again from scratch. And again, based on our experience of having done Ethernet drivers in the past, it feels like maybe about a man-month of work. All I know about Ethernet drivers is they are absolutely brilliant for having really obscure bugs that completely crash your machine. So they're a pain to develop. Now, if we think of those as completely independent and can be done in parallel, which they effectively are, with the best will in the world, we might just be able to get them done this year. So hopefully, this side of Christmas, we'll have the Pi 4 working on RISC OS. We'll see. If you want to see up to the second granular detail of what's going on, you can of course look in GitLab because all the development is happening there. So if you like looking at stuff like this, that's the place to go. I think most of you can guess what the next big things are that we want to do. And I have touched on this stuff in the past, but I'll say it again anyway. We've got things like the Pi 4 with 4 cores, and we're running on one of them. There's 3 cores sat there twiddling their thumbs. It would be nice if RISC OS could make use of those other cores. There's obvious performance benefits to be had. Monitors, many of the modern systems support more than one monitor. RISC OS doesn't. So at the moment, you've just still got one monitor. So there's quite a few things that we would like to do to support that. I don't know how many of you like having a setup with multiple monitors, but I certainly do, and I think it would be great if RISC OS could support that. Putting money in bounties, we want to keep working on that, and I think Rod potentially are doing some of that work for us, so if we can make sure that we have a good relationship with RISC OS developments, then some of this can happen as part of that. And another side of it is finding, lots of people here at the show are finding niche uses for RISC OS, which is brilliant, especially if they can find niche commercial uses for RISC OS, because any niche commercial use is inevitably going to feed some money back in to develop other things in RISC OS. They might have some key feature that they really need, and then that obviously, because it's open source, can feed back into the community. And the other thing that's kind of the looming problem is increasingly newer ARM chips are moving to a world where RISC OS won't actually be able to run on them at all. And it's a bit like the old transition from 26-bit to 32-bit, not 36-bit. I hope we never see that. So 26-bit to 32-bit was quite a big problem. There's a similarly sized problem coming up, if not bigger. So we need a plan for how we're going to tackle that. And there's various options available, each with pros and cons. But we're already seeing chips now on the market that only work in 64-bit mode, and quite definitely RISC OS wouldn't run on those things without some sort of emulator. So this is a growing, looming obstacle on the horizon for RISC OS that we need to solve. Okay, that was it from me. Any questions?
You mentioned being able to run multiple cores. How far in the future any ideas?
Oh. Which parallel universe should I base my answer on? We are making some progress. Well, I say we, Jeffrey Lee we. There's kind of some foundational stuff that's happening. I think within the next year we could see kind of specialised uses of other cores. So there's certainly stuff that we did in the past at Acorn and Pace, where we had processors with more than one ARM core. Even back then, we would have the body of RISC OS running on one core and stuff like an Ethernet driver running on another core. And then all it has to do is say, here's some packets, RISC OS, come and deal with them. So I think we can do bits like that to make use of cores, but to have a general purpose solved multi-core, again, it just feels like it could be several years away. And it's really hard to call because it depends what our developer in the community chooses to focus on. It's not something that we're directly putting our time into. That's not a very good answer.
Well, the other one I wanted related to that was the graphics.
Mm-hmm.
Whether it's possible to get the graphic
This is difficult. That may be one of the niche purposes, is have some sort of plotting library that just does blitting and plotting and stuff that runs on one core and talks to the displays. And then RISC OS can just throw plot commands over the fence at it, that kind of thing. So yeah, that's a simpler way to solve the problem, which someone may choose to do. What you really want to do is try and do it in a way that's not architecture specific, so that it only works on a Pi 4. You really want it to work well on many systems, which then kind of says maybe this should be a core operating system function rather than a bolt-on. Any other questions? Blimey, this is the fewest ever. I must have done a good talk. Right, thank you very much.